Hi, and welcome to the APL show. This is the podcast for notation as a tool of thought. I'm Adam Brodzewski.
I'm Rich Park.
And today is a very special day because we have our first guest.
Hello.
We'll get back to him in a moment. First, just a couple of announcements, upcoming events. The 19th of June seems to be a very interesting APL day because on the two opposite sides of the globe, there are meetups. There is the Northern California APL group, which have their meeting, and they are going to have a guest from Dialogue talking about data input-output, and there'll be a discussion there as well. That is on June the 19th at 17 o'clock UTC, and then there is in Tokyo meetup, something they call Let's Talk APL JK, and that it is at 10:30 UTC. So that actually happens first.
Are they both online?
They are both online, yes. So with that out of the way, and we have our guest. Do you want to introduce yourself?
Yeah. Hello, I'm Silas Poulson. I work at Dialogue as part of the interpreter developers, mostly working in C, although stumbling around various bits of APL as I discover them.
Yeah, so Silas is one of the fairly recently hired interpreter developers. And I suppose, what have you... we'll talk about the reason why you're here in a second. What are you working on recently?
Mostly just small works, but
Like bugs?
yeah, bug fixes that people have reported, or although I've been they're mostly kind of edge cases. Like there's one looking at recently of doing quad OR of a function as left arguments, and
Right, yeah.
because the defund can't return a function and it's trying to. Yeah. Yeah.
It's funny, there was like an experimental thing long ago, but I don't know if that used quad ORs as the mechanism. Was that a version 6?
It's like conference edition.
Conference edition, yeah.
Yeah, I don't believe it was. Internally, there's not really a difference between quad OR, and we haven't explained to the listener what those are. Even.
No, I was wondering whether to gloss over that or not.
Thing. I don't think so, because the idea is a function can return a function, which is already the case in Dialog APL, but not all functions are equally privileged. Tradfuns, these traditional procedural functions, can actually return functions. I'm not sure if that's a feature or an oversight in implementation, but I certainly use or abuse it depending on your perspective on occasion. But even a function like execute, the primitive execute, can also return functions. So if you execute the name of a function that returns that function, and then you can apply that. So occasionally I will write something like open paren execute, and then some function name variable, close paren, and then an argument, and then it will evaluate that function name to the function itself, and then immediately apply it.
That's a way you could have a bit of a fudge towards an array of functions that you choose which function you want to apply based on some condition that's actually selecting a bunch of names or possibly actual definitions. It could be from an array of such things. Go on.
Yeah. Adam's thing I've seen where you've got a namespace in the functions, I feel is better mechanism, because there you can actually differentiate, because quad OR it's only changed the name class.
Oh no, we're not talking about an array of quad ORs. We're talking about literally an array of character vectors where each character vector is the name of a function you've defined previously, or it could literally be the body of a defun or something, I guess.
Or even a primitive.
Because execute just evaluates APL code, right?
Yeah, so you could have indexing into the character vector plus minus, the symbols plus minus, and then execute that. That gives you an actual plus or minus function that you can then apply.
Yes, and I think that was one of the things you showed, of why you can't do a static analysis, because it could
Yes.
be a plus or 2 or something.
Yes,
You
what
go
comes out
randomly.
there doesn't have to have a consistent syntactic class, and APL will completely dynamically just insert that value, whether it's a function value or an array value, into the current expression that we're in the middle of. So yeah, if you select a random character from the character vector plus and 2, then that whole thing is in parentheses with 1 and 3 on the outside. So if it selects the 2, you get 1, 2, 3. And if it selects a plus, then you get 1 plus 3, which is 4. And that's an entirely different syntactic structure of your statement, for good or for bad. That said, don't do that, please.
Yeah, I feel a lot of the dynamic things that they're really nice to some extent, but they're really awkward to actually try and implement. And
yeah, I don't think I've ever used that in production code, but I think I've on occasion gotten the function value out from a name, where name of a function is passed in, and I need to actually apply that function. So that's one way to do it. The other way to do it is, of course, using an operator, where you pass the function in as an operand.
Yeah.
So Silas wanted to come on for various reasons. One is to give like an implementer's perspective sometimes when we talk about things like this. It's pretty interesting. I think we talk about notation as a tool of thought, but obviously getting that from a concept into reality involves all kinds of, well, sometimes weirdnesses that are interesting to explore, but also as a relatively new APLer, right? You say you program mostly in C. Is that what you did previously as well? It's like most of your experience in C.
I think I'd only started at APL the year before. Kind of, I'd started at Dialog, and it was and even then it was kind of mostly just a small subset of the ones I was familiar with was what I'd use, and it was kind of playing around with it.
You mean like primitive or like constructs in the language that you're familiar with, or?
Yeah, and kind of there's syntax, various primitives. I didn't really use a great deal of primitives. So like there are some I knew and kind of, and then, or say the split on spaces one. I didn't really know why that worked. I just knew.
Oh yeah.
These 3 characters together give you splitting.
But isn't that more like a natural language as well? You might use some compound word or phrase that could even be an idiom in the real sense of that term. So the words literally mean something else, but you never really thought about it. You just use them because you know what it does. Right?
Yeah.
That's quite natural.
I think so. But then it's fun to like learn about things later on. Like even with like say natural language and stuff, you go like you either learn that idioms that you never thought of, or you learn new meanings for things, or where things come from. But yeah, so as a relatively new APLer, you're navigating the sort of the world of or APL idiosyncrasies, not just in the unique aspects of the language and the syntax itself, but also the terminology used. And we talk largely about notation, which I guess is mostly about writing things down and using that for thought. But obviously, as people, we have to express concepts to one another, often in more verbose terms. So we need to explain concepts, usually in natural language, and that involves assigning like verbal names for things.
I've heard about,
and that's the whole world.
About people who use APL and like to use APL who cannot see, which I found really interesting. Because for me, a large part of it, in the appeal of APL is the visual aspect and skipping the verbal part. I don't think about the names of the symbols as I use them. I directly associate the symbols with their meaning. And also because it's much easier to keep in mind the concept of what this symbol does without having, and for example, English words restrict you um, into a narrower set of users.
Yes.
Does that
Well,
make any sense?
I suppose so. Thinking, because we've got rank and atop and kind of things where they have different names and kind of having to pick one. Like I know I tend to say selfie a lot when I mean both constant and commute.
Yeah, the names are
And
more in the way than they do me a service. They don't help me to think about what the function does. So, and for example, um, we have a reverse function. It's called that. eh, a circle with a vertical bar through it, circle style. If you have a two-element vector, or for that sake, a two-column matrix, then it's also a flipping the two elements. Yes, technically speaking, it's the same thing as reversing, but I might not think about it like that.
Yeah.
And we have it in reduction. So people think of things like sums and products and so on. But sometimes I have pairs of things and I want to insert a function between them, in which case a reduction, it just inserts the function once between the two elements, and it's really a type of apply or insert and not so much a reduction. So uh, the if I just associate the slash symbol with this action of putting that function in that position, I don't want to mix in any verbal part in that. That said, I think APLs have done put in quite some effort in trying to come up with good names for various concepts and functionalities. Well, sometimes you still use obscure terminology, and you came with something, Silas, that you were looking for, right, and couldn't figure out.
oh yeah, so kind of I found it really difficult initially to figure out how to open files and kind of just like because the terminology is different because it's tying in APL, whereas it's the same idea as kind of file handles from Unix and which I was very familiar with, but it's the terminology is different.
I surely would have been well aware of file handles. Did they just not want to call it quad handle because that's just a bit long?
It might be a historical reason for this.
It could even be.
That files were actually, well, for a lot of things I think in APL, the terminology might differ from modern day terminology, is because APL was there first. And then maybe the world settled on some terminology for some concept, but APL had already established, the APL community already established their own terminology for it, and APL community has tended to be quite closed off from the world outside.
Yeah, because you see that with kind of with lots of people, or my impression anyhow, lots of people of kind of going that APL was the operating system, and all you had is kind of a terminal
Right.
connecting to a session.
And APL actually introduced files as a novel concept.
Really?
I'm not saying that APL was the first system to have the concept of files, but on the systems that people were using, it wasn't a given thing that, oh, well, there's an operating system below, a file system below, and you just go and deal with files. Every programming system available had to implement a file system by itself and its own way of dealing with files. And you can actually see a hint at that in the naming of these system functions that have English names in APL. So you have some of these quad F something for what we today call component files, and then you have quad N something for what we just call normal files today, but we in APLs tend to call them native files. So just F for file, that whereas we today call them component file, that sounds like that is the original thing, and that's exactly what it was. There was no OS file on the early APL system. The APL system itself implemented this way of storing things in permanent storage, which was this file system of having components numbered components that are bound together in a certain
And those are
associated with a
all
certain name.
APL arrays
Yeah, so
at that
it's a
time.
collection of APL arrays.
Because your whole operating system being the APL system,
Yeah.
everything's
So and there's no directory structure, and so it was just there was the name of a file, and then it had components.
Yeah, and I suppose as well that's better if you're doing like kind of the old style kind of reel to reel tape where it's you don't want to have to jump around because it's going to be really slow to do the access. You want to just read it in one chunk.
Well, you a chunk at a time,
Yeah,
one
but
component at a time. Yeah.
it is more just thinking about the seek time and
Yeah, I'm not sure how that. Well, I don't know how it was implemented. I suppose there was some kind of like file location table that,
yeah.
and then it had to spool over there to fetch those. But there wasn't the concept of a plain text file as we have today, as the most fundamental type of file, didn't exist. There was nothing you could do but to store an APL array as a component in such a file. And that actually has performance implications, good performance implications, even today. Whereas a text file could just be plain text in some kind of encoding, an array that's in memory has a bunch of meta information, and especially an APL array that has to have a shape and type and so on. And the way these files work today is that you just have a memory dump of that segment of memory stored in the file. That makes them super fast. There can be nothing faster for permanent storage than literally reading what's in memory and dumping it to disk, and the other way around. Reading is just literally taking what's on disk and writing it into memory, and that's it. Now you've got your data there. So and so I think that the terminology they came up with at the time to tie a file, they also I think that shows better than the file handle that it belongs to me now. You can't go and change it because that will create all kinds of issues. So I've tied it up, and then I can untie it. So it's almost like
I was also thinking
releasing
about
it.
handles, like
How do you
handles a thing you grab
unhandle?
onto.
Yeah, it's less then many
You've
people
like grabbed, you've
can
bit of
grab onto
file.
the same one, which there is such a thing as a shared tie.
Yeah.
Um, but I like the terminology of tying. And then the file handle in APL, a tie, is just another array, which is just a number. Everything in APL is an array, and we use often numbers as storage device for various types that would otherwise have their own separate data type in other languages. So there are very few types in APL. And so a tie number is just an integer, just a number. And you can today you can also allocate them. You say, okay, give me a tie number for this one, and you get number 45. And you keep that around in a variable, and then you untie it at the end, number 45. You don't actually need to know what it is, but it is just a number, and potentially you could do math on these numbers.
Yeah, you could say
Yeah,
I want 5 contiguous files. So you go,
yeah, you can look for, yeah, you can ask the system what are the currently used tie numbers, and then you can find the gap such that you have contiguous tie numbers and use those. Today there's you can give a 0 to quad n tie or quad f tie, and it will auto allocate you a number. But I remember when I was little, you couldn't do that. I'm not sure why they didn't have that functionality. But the way you would do it is you would ask the system what are the current tie numbers, quad n nums or quad f nums, and then you would write a little bit of math to figure out what is the first number that's available. The lazy one is just max number plus 1. But then as the system chugs on, you get larger and larger numbers. Really, you want to find the first number that's not
yeah, which
Okay.
is
So
kind
go.
of how internally, because I was seeing Richard is kind of see he was fixing something there, but picking the the first number, it goes through and marks and then does a where effectively, a where on the knot of. I think it's kind of iota without and then do a where.
Yeah, you can do that. Although that's possibly wasteful to do that.
Well, if you've only, or maybe it was one of the end files where you've only got 255 or 256.
Oh, really? There's a limit to that?
Yeah.
I didn't even know that. Yeah, then it
Yeah.
doesn't matter. I was thinking if you've got like a tiny number of several thousand, and
No,
is that
it's I think it's 512 for native for F file F nums and 256 for N nums.
Oh, really? Okay.
Yeah.
Learned something today. Probably
It
also
was-
depends on the exact APL system.
Yeah, well, that's ours as I'm aware of it, and probably others were just like will bump the arrays. It's because you need the metadata kind of, because it's not just APL. It's APL's got to the interpreter's got to live with all the other systems.
Yeah.
So it's got to maintain all the information about the files it's got open, and there's only a limited buffer we've allocated.
Interesting.
Mm.
So that's file ties. And
That's a kind of, I think it's funny that's a kind of abstraction over what, when we were reading about, I can't remember whether it was a common language for hardware, software applications, or description of finite sequential processes. Some of these early sort of pre-APL Iverson papers, they describes files and accessing them, but really it's like using encode and decode, which had like a shorthand for base 2, like the default.
Yeah,
default argument.
J's got that still, hasn't it?
yeah, monadic
encode and decode.
You could have a 2 on the left. Basically.
And that was used for literally accessing bits in memory.
Yeah.
And almost a more direct thing. You're talking about expressing the access to a new tie number in terms of APL primitives doing and not unaware, which is quite funny.
I'm really curious why did they drop the monadic forms of encode and decode when they linearized APL from Iverson notation into what we know as APL?
Yeah, because
that's really curious.
We were reading yesterday saying where it's kind of building the golf ball, but I don't know. Have you explained that previously?
Probably should explain the golf ball, even if we have.
Yeah. Okay. So how I've seen kind of history, it's when you're old printers, sort of like a typewriter, had the letters in metal, and one way of doing it was rather than having a peg for each letter, you have a single sphere with all the various letters stuck on it. And if you want to print a letter, say F, you've got to rotate. So your ball there and say it's there. And you've got to rotate and whack. And it finds where the F is and it turns and it hits it on the paper. And so when you were doing it for APL, they had to work out, go in as part of the linearization process, it seemed, going, oh, we've got this cool paper notation. How do we get a computer to it? We've got to be able to type it. And as part of that, they mentioned that they were thinking about every symbol and every symbol having to have monadic and a dyadic, purely because they wanted to make sure that every character they managed to fit on the printing element was useful. And it seemed as well that was where reshape comes from as a dyadic, although.
Well, reshape came from thinking how can we make use of the dyadic form of the shape function. But that still doesn't really explain it. That same symbol, the decode symbol.
No, it's odd that they haven't done that.
Yeah. The decode symbol was already there in Iverson notation, monadically and dyadically. And monadically is just binary decoding, and dyadic was with any custom base. And then they added encode for the other direction, which makes sense, and turned it upside down, and then removed the monadic form. Maybe they, It's so much
I
about
wonder if like
brevity.
early days they're doing so much hardware systems design, like it made sense to have a shorthand for base 2 stuff, but then in the general applications that it found itself in, maybe people don't do so much converting base 2 that it didn't seem worth it. But again, it didn't seem like much to have. It seems like so little to just include the monadic form when they didn't even replace it with something else. It wasn't like the monadic form of the encode and decode symbols, uptack and downtack, became something else, did they?
No.
They were just outright lost. So yeah, it does seem odd.
That's what I was just checking.
In most APL systems today, that
I had to
they're
think
just
for a minute as well.
strictly dyadic functions. By the way,
Yeah.
those encode and decode are interesting names. Speaking of this terminology, and a lot of people seem to have problems remembering
I
which
think
one
that
is
was
which or what the names are.
Michael Higginson when he
Yes.
in his
Yes.
contest
Yeah. Although
talk was saying, I remembered that I had to use encode and decode. I remembered that's what they were called because I could always remember that I could never remember which one was which.
yeah.
Really?
Although it's interesting because I sat next to Ray Cannon when I think is that his surname? Ray?
Yeah.
Yeah.
Well, if we're
If it's
thinking
Ray
about
Cannon you're talking about, then yes, his name is Cannon.
the old chap who presented.
Oh no, that's you're probably
No,
right. The
Ray
book guy, Ray Polivka, yeah.
Polivka, yes.
Ray Cannon's another guy who does simulations of ants and cool Mandelbrot
Yes.
images on
Yeah, but
Facebook at least. Might be on Instagram as well. Oh no, TikTok. Ray Cannon's on TikTok.
Really?
Yeah, if you're a Gen Z kid listening to this, check out Ray Cannon's trippy visualizations written in APL on TikTok.
And
shout out.
Ray Polivka.
Sorry, Ray, you were talking. Oh.
Yeah, Ray Polivka writes a book about they're teaching APL every couple of decades, and
It's worth shouting that one out because he is
Yeah.
Keen for feedback on the current draft of his book, Ray Polivka, who is the Ray you were talking about, Silas.
Yes.
We'll
that's on
link.
aplclass.com/book. Yeah, we'll leave a link in the show notes.
Yeah, but he was saying they were. I can't remember what they weren't originally encode and decode. They had some other nicer name. I can't remember what he said they were, but
You know, do you remember seeing? Oh, I've got one of the PDFs of the old papers. Don't pause for my account. I'll keep scrolling to see if it's mentioned by name, but I know that the symbols are used.
Wait, the old papers, you mean?
Yeah.
The old ones, I think, only had the base evaluation, so that's decode, and no encode, strangely enough.
But it's the question I've got is whether they were called, whether they were referred to as that. Because actually, this leads in nicely. I was going to ask about. You talked about a sort of system thing. System things are funky in APL because in some sense, they're not considered part of this like core notation. Like we said in these early papers, they use the core notation to describe operations on the computer system, but now there's like these abstractions on top, the quad functions, the system functions that start with this rectangle and then actually have a name, and they have more of the flavor of like a conventional language, only in the sense that it's named functions that take some arguments. They still have this APL idiosyncratic flavor of the arguments are a little bit obscure, and you have to like always refer to the documentation to know what's what and in what order to give it and what this number means.
But they follow APL syntax.
Yes, but you can't really chain them. And well, you can a bit, but you're less often see them chained together in these sort of compositionally styles. You do. I've seen you do it sometimes, Adam. To be fair, but in a lot of APLers don't do it that way. They'll sort of wrap their use of a system function in a utility that feels a bit more conventional in its flavor. You know, they like,
especially for things like this. Coming back to the file ties, I need to tie a file and read it.
Exactly. They'll write a function called read text, and you know, this is before quad get or something, and then it will tie a file, and then it will read the data as text data, and then it will untie the file, and then that's the, you know.
I will chain those together. You can even make a tethered function using those.
Yeah,
Well,
I
exactly.
think
You'll do that. I'm saying a lot of people
yeah,
don't.
and I feel like I've seen one you had about putting the I think it was a F tie or a tie of some form and kind of next to and doing kind of left tack that and then so
Yeah, so if you tie a file, then using quad ntie, that so then you take it actually takes the file name on the left and then a tie number on the right. So often I will bind a 0 as fixed right argument to that so that it auto generates a tie number, that's just one that's available. So that is a derived monadic function. So the argument is the overall argument is going to be the file name. And I'm applying this derived monadic function of quad ntie jut 0 or bind 0 on that returns the file tie number. And then I want to get the data out before it's untied. The order is important here. And there we need to supply quad nread with a couple of things. So we need to know first the tie number and then the conversion code, which is how we're to interpret the actual bits that are in the file, which is often something like 80 or 83. That's for just single byte characters or single byte integers. And then we need to say how many we want to read. And that's often all of them. So that's a special code -1. And then where we start, which is just at position 0. That's optional. So then I will concatenate to the result of the ntie the conversion code and the count. That gives me a 3-element vector. Throw that at quad nread, which then returns the actual data from the file. And then I want to take the so this is a kind of a top, right? We have quad nread a top concatenate with conversion code and count. And that is being applied to the tie number we got out from the ntie. Then I also want afterwards to do something separately, which is untied quad and untie. And then I want to discard the result of quad and untie because it's not that interesting. It's the tie number of the file actually being untied, which is going to be my file. And I want to return the result of the nread. It might not sound like it, but that's a fork. There are two functions I want to apply to the tie number. I want to apply first the nread on the concatenation with the other parts of argument to the nread. And I want to apply the untie. And then the function I want to apply between the results is the one that just selects the red bytes. So that means the middle tine of the fork is a right tack. It's important that I can't swap the two because the right side of a fork is evaluated before the left side of a fork, and I cannot untie first and then read, and it's too late.
Is that by implementation sort of happens to be how it is, or is that defined in the spec for a fork?
I don't know if they even.
I think in principle they could. Great, yeah.
No, but the APL in principle goes from right to left.
Yeah, true. So it makes sense for it to go that way.
And the binding of forks as well is from right to left. Right? You must evaluate or group together the functions in a long train and evaluate on the right before you go further to the left. So it makes sense that the right tine is evaluated before the left.
You might have a fork atop or something.
Yeah.
Yeah.
So that makes sense. So then you could write it like that. So if I am not making any mistakes, then so it'll be a fork atop the ntie. And the whole thing will then, so the fork is going to be quad n untie, write tech, quad n read a top, concatenate, bind, negative, oh, so it was first going to be, say 80 and then -1. And then that whole fork, so we need parentheses around that. And on its right, so it takes as argument the result of quad n tie bind 0. Because we want 0 as right argument, but we want the actual outer argument to be the file name. So this is a whole tested construct here. We got a top of a fork and the derived function from bind using these system functions. I think it works fine. Some people frown on that, say you don't do that with system functions. But I think it's part of the beauty of APL that even such things as system functions use this regular syntax. And so when people complain, oh, the syntax of APL is so complicated, who can understand that kind of thing? No, the syntax of APL is really, really simple. It's just this rule set of monetic dyadic functions, and then you've got operators that take them, that's it. Everything falls into those categories, even the system functions.
Yeah, and then the only confusion I've seen is with trains and just kind of the ordering, but then that's just it's function application. It's just
it's a type of function composition before you apply them.
It uses the syntax.
The syntax of juxtaposition of functions.
That's yeah. I wanted to come back to, because I've just found a bit in one of these. This is a 1960 description of finite sequential processes. And as far as I can see, I haven't comprehensively analyzed the text. I've just found a paragraph where it's mentioned. He doesn't seem to he calls very few of these things anything at all specifically. In the prose, he uses the symbols, the notation, to express the concepts, but then describes them in English, but doesn't sort of name things. So here he says the base B value of the vector x is denoted by B uptack x. And that's it. He doesn't go like the function, we would say like the function decode and then put maybe the symbol in parentheses, blah, 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 because then I guess we want to speak about it with one another in a sort of compact way. But he doesn't seem to do this at all in these early papers. He just sort of uses the notation, describes what the concept is. So I also want to ask you, Silas, about, because APL has a fair number of like concepts which are not, okay, maybe not anymore, especially unique to APL, but like used in a uniquely APL-ish flavor, and like it has this whole multi-dimensional arrays are so central, so there's a whole bunch of concepts around that maybe aren't in other places, but also there are a lot of concepts that are obviously identical to similar ones in the rest of conventional programming languages and computer science.
Yeah.
And I guess we can go either way with this, but like terminology that you found odd or confused you because it's just you can go either way. Either it's the same concept as something you've already knew, a bit like the ties and the handles you were saying, but it's called something different in APL, or something that's called something different because it is something different. I don't know.
I suppose, yeah, a lot of the simple glyphs and like, so just looking at language, well, kind of the first chunk, they're all same. Like the assignment took a moment to get used to, but that's just okay. You've got an arrow now instead of an equals, or kind of equals colon.
Yeah, and there are a couple of people that do that now. There's like in R they use that, but you have to write the arrow as a less than hyphen.
Yeah, and I feel like doing a right arrow, Haskell's got for when you're doing lambdas.
Oh yeah,
I think it's an arrow.
Even
it's like an equals greater than.
Yeah, JavaScript does this as well for arrow functions, but that's not an assignment. That's showing a function from this to that, right?
Yeah. No. I was meaning more just, but it's a different syntax, but it's a simple idea.
Yes, right.
The ones that initially confused me is I think the set ones did a bit, just because they're not pure sets, and so I'd kind of
right, yeah.
But
we
never really call them set functions in APL. We call them by names that people
sadly,
associate.
Adam, you and I have definitely called them set functions, and we've referred to them in some
have,
stuff,
but I think they're not
in like
officially
webinars and that.
grouped
No,
like that.
officially they're not.
But the names of them imply set functionality.
Yeah, and they
union,
look
intersection.
And they look the same as well.
They
Like
look
Well,
the
yes,
same.
yeah.
But they're more like multisets than.
Yeah, but you've got to
Not really either.
you've got to notice that. I know this is something you've got with select and stuff, but in kind of doing the indexing and kind of knowing when do I need, like, because I've been doing square bracket indexing recently, and kind of doing when do I need a semicolon on the end, or when do I not, and kind of things there surprised me. And just trying to remember, like, less so now, but more trying to use squads. And it was kind of having to, you've got to enclose, and it's like, okay, that's a bit odd, but
well, we had a previous episode about this.
Yeah. No, I know there's things, but it's just, it was a difficult thing initially.
But was the terminology difficult, or it was just how exactly
concepts.
these primitives work?
No, it was more just how to do it. Whereas, and kind of, just a more functional way of doing it, because I'd only ever really seen the square brackets where it's going like you're indexing by that.
I find when I teach people that they do struggle somewhat with the terminology, and that's somewhat indicative of the nature of APL as well. A lot of people will not readily accept that the number 42 is an array.
Yes, that still trips me up every now and again. Have to remember that a number's still an array. It's just one with no shape or anything.
Well, it has a shape.
It
has a shape, but the shape is
empty. Yes.
So this is maybe something we can go into a bit. Everything in APL is an array. That's not really true, because functions are not arrays. But all data, I like to say, is stored in arrays, even if it's just a number or a letter. And even actually if it's a dictionary namespace, it's also just an array. And they all have this uniform way of behaving. But people get tripped up on the terminology. We didn't need to call them array. We could call them whatever, data, stuff that you work on. But every array has a shape. Every array has a rank. And these are maybe words that can confuse people if we use them slightly differently than others do. I think, though,
I might pull up on namespace, because really it's like the reference is a scalar, but the place where the stuff lives, I feel like, is something else. You know?
Yeah.
And that's only because it has the reference semantics that are unusual in APL.
Yes,
but that didn't need to be. Even if you had a dictionary type that didn't have reference semantics, it was just passed by value, it would. What kind of beast would it be? Would it still be a scalar?
Well, I'm saying that the thing that is a scalar is the reference to the namespace. It is not.
But not the value of the namespace itself.
Yeah, I think it's a fairly important distinction when you're learning those concepts.
What's the length of a dictionary of things?
Yeah, exactly.
Number of entries, or it's just one. That's just that one dictionary. We actually have it. I think it's maybe one of the rarest known functions in dialog APL is monadic squad.
Oh yeah, no one knows what that is.
It's materialize, isn't it?
That's what it's called.
He knows the name of it, but you know what it does.
Yeah, it's the object stuff. It's like going, give me an array from this object, isn't it, or something like.
So if you have this object, which is an array, but it's a scalar, and it is a collection type object, or at least it has a property, a default property, which is a collection of things. So classically, people in some other language in APL will create an array object, a list object, and then will maybe append elements to it. Whereas in APL, that's very fundamental. That's in the nature of the array itself. But we do have object-oriented programming as well, and we do have interfaces to languages where this is a thing. So, for example, we have tight integration with .NET, and the .NET has the concept of collections. And then materialize will materialize out the elements that constitute this otherwise scalar collection.
So if you've got if you create an array in .NET and then you do materialize on that name, it gives you an APL.
It will give you an array back where every element of the array is a .NET array element, whatever the type is that this array is made of.
So it doesn't convert everything to an APL stuff.
Well, if it's types that are otherwise automatically converted, numbers, text, whatever, then yeah, I'm not even sure text would do that. Probably the string, it would get string objects. I don't know if you have a collection of strings, then you get so that collection itself is scalar from APL's perspective. But if you materialize it, you get an APL array of .NET string objects instead. And then plus, I don't think strings are considered iterable. But
in .NET, or
yeah. So otherwise, you should be able to materialize those again and then get out characters.
Can you not iterate over a string?
You probably need to convert it to an array of characters first.
Okay.
But it doesn't really matter. This is the concept of materialize. It's only really there for everything else in the APL. In the APL itself, core APL, you don't really need it. Although you can create objects with a default property, and then materialize will exchange the scalar object for whatever array the default property is, which could be an array that has dimensions or not. It could just be a scalar value as well. But I mentioned before shape. Every array has shape, and we take that for granted. It's so fundamental for APLers that every array has a shape. But what does that even mean? Notice this is not the count. It's not the length. If you have a matrix with 3 rows and 2 columns, then it's shape.
Yeah, because it's number of dimensions.
That's the rank.
Shape is
the collection of lengths along each axis, and data arrays are data elements stored along 0 or more axes. Right? So 0 or more, so that means that if you have a scalar, or which could be a symbol scalar, like just a number, there are no axes. So then all the data, which is the number itself, is stored along these 0 or more axes, in this case 0. And that also means you need that many indices to pinpoint any particular element. And which means that the access to individual elements is immediate, no matter the dimensionality of the array. And here we have a big difference from languages that just use lists of lists. So they might say, oh, well, we have matrices, we have a list of lists. But it's not really the same. Firstly, if you try to take the shape, or they would say the length of that, you just get the number of rows or number of columns if they use a transposed representation. Some languages do that. But the shape, it's kind of pervading the whole thing, saying along each axis, what are the lengths? And then you can directly go in and address a single element by giving indices, all the indices along all the dimensions. And if you try to map over an array, then it doesn't matter how many dimensions it has. It's still direct mapping. So imagine this in, say, JavaScript. You have a list of lists. And then you try to apply a function. So you do a map on that. Then you will the argument given to the function every time around is a whole list.
You need to map. So
You would have to map, right? But then if you have a 3-dimensional array, you have to map. And if you have an n-dimensional array, you don't know how many dimensions it is by the time it comes in. It gets really complicated. You probably want to do a recursive solution. Whereas in APL, all the elements along any dimensions have the same kind of status. They're all immediately visible from the surface, addressable from the surface. I think the whole concept of shape and what we call shape is something that can be confusing to people. And then the length of the shape is the rank, which I think corresponds exactly to tensor rank in mathematics. It's just the number of dimensions.
Yeah.
I have found occasionally with shape is remembering which way round. Like if I'm doing a reshape of a matrix, having to remember which ones were columns and which ones were rows.
Oh, really?
Yeah.
So and if you do more dimensions, even more. Yeah, layers, rows, columns.
No, see, I mean, I've seen in some. I think the Zark tutor has got this where like they have a whole section where teaching you to reduce along different dimensions, but really it's again attaching. You basically are attaching real world concepts to the dimensions. You know, you're saying like
these are the locations and these are the days and these are
the
products, that kind of thing.
Products, locations, days is pretty common, yeah. Things
but that wasn't Silas's problem. The problem is just which order do the dimensions come in.
Well, no, what I'm saying is like for in some contexts, I think people largely ignore the direction, right? And they're just talking about the concepts. It's true when you're like learning, you're just playing with like vectors, matrices, and 3D. So you visualize it, then you need the direction. I'm saying that some people avoid that by just not thinking of them as like a cube-shaped thing at all, or a hypercube thing. They just think of them as like, I don't even know what, just like a filing mechanism or a, you know.
Well, you were saying, Rich, when trying to explain doing the enclosed with axes, kind of behold style, rather than doing a hypercube idea of an array, kind of.
Oh yeah, so some time ago, Silas was asking me about how enclosed with multiple axes.
Yeah,
works, and I had to think for a minute, but then it was like, because I think a lot of early APLers did think a lot in terms of acting along these dimensions, whereas the leading axis approach is to think in terms of like rank n cells, these subarrays, and you can express enclosed. So enclosed axis is left shoe and then square brackets next to it, and then you put in the axes along which to enclose. But in there is, you know, and then I start to explain it in terms of enclose rank something and dyadic transpose.
Yeah,
which is sort of, I don't know, it's hard to say if it's a more fundamental way to express it. Like I said, like we've been talking about, a lot of the early APL concepts, like I guess were natural to think about in that way. But then when you try to put a kind of framework of uniformity across the whole language, it turns out it feels like actually they're more like ad hoc definitions to things. Whereas like rank operator is very uniform. It acts the same way for all the functions on all arrays, and dyadic transpose too. Whereas you have to kind of, well, when you've learned APL like that, you with leading axis theory sort of in the forefront, you have to bend your mind a little to understand the axis way. But I'm sure, I'm sort of imagining, but I'm sure that it must be more natural for a lot of people who learned APL before to think in terms of, well, you just want to sort of grab all the stuff down this axis and box it together. And then when you put two axes in, you just want to grab all the stuff down this side and along this way. And they're, thinking in terms of like.
And I saw something
these
really
hypercube
interesting.
shapes.
I was in the APL Germany spring meetup, and somebody who was a regular there is called Jacob Brickman. He showed me a regular operator, so not special syntax, and an axis operator, not a rank operator.
Ooh.
And he sold it as it can do everything that you can do with the square brackets, but the square bracket axis is inconsistent. Right? You cannot
Oh,
write an
yeah.
operator. We have this principle. You can't write an operator that does the square bracket axis thing because it's just ad hoc. Well, you can write it, but you have to look at the operand. You can't. There's no general stating of it.
Yeah, whereas rank, it's I want to dig
Rank
down to
is
this level.
uniform. So he had an operator that does exactly that. And I was like, wait, that's impossible. That can't be done. And but what is happening there is that his operator took a multi element axis and more than what you have with the square bracket axis. His point was that there exists an operand to his operator such that it matches the behavior of the square bracket axis operator.
But you have to provide.
We have to
some
provide more
information.
information. So if you have a 2 in the square brackets for some function, that corresponds to a 2 in his operator in one of these slots. And the other slots, depending on the particular function, are implied by that function. But you could state them explicitly too.
Okay.
That meant everything was very verbose and kind of clunky to use because you always have to spell these things out. But I thought it was interesting that he's kind of unified everything like that. And the way it worked is you could actually think of it like that it's a mapping. You're saying I want so you have one argument that's specifying what axis the function is being applied to and where the result goes into the result, where the result of those applications go in to the final result. So so you could kind of see how this would work. So let's say we have a reduction with that axis. We can see that, well, we split up. So it's really just an enclosing along these axes and then applying one each. And then we need to do a mix of putting them together again or not.
Okay.
Right? So we just specify exactly where does the function go and do in each? What is the collection of items that we're doing the each on? And then what do we do with the result? Do we assemble it together again? Or do we join x's and so on? So for him, it seemed that it's easier to think about everything in these terms. And it actually is more flexible than the rank operator because you don't need to do the transpose. It's packaging.
It's part of that. Yeah.
It's packaging the rank application and the static transposing before and after into a single package. So you could actually think of it like this, right? You can do anything, is the idea, by doing a dyadic transpose function application using rank and a dyadic transpose.
Yeah.
Okay? So the first dyadic transpose, you just need to supply a vector of numbers. That's the argument to the transpose. Then the rank application of the function, you need to apply the function and the rank specification, which could be 2 elements at most. I mean, it could be 3 if you want to make it ambivalent. Doesn't really matter. And then you possibly need to do a dyadic transpose again, which is another vector. So that means that 3 simple vectors, numeric vectors, and a function is actually enough to do any kind of function application. Right?
Yes.
on any, yeah, with like some structural bent.
Yeah, dyadic
Yeah.
transpose left argument, rank operator right operand, and dyadic transpose left argument.
The transpose is to do move everything into position. So
Yeah, and then move it back again to where you want it to go. The last transpose may just be a 1, 2, 3 transpose, which doesn't do anything, right? The first one could also be that, but that's the no up argument. So that means we can create a dyadic operator which takes a function on the left and a 3-element vector of vectors as right operand. And all it does is rearrange the right operand. So one element becomes the left argument to a transpose. The second, the middle element becomes the operand to a rank operator with the function operand, and then the left element becomes the left argument to the dyadic transpose. And now you've got a single operator that can do everything that the bracket axis can do.
Well, I assume this guy's thing's a little bit more elegant than that, was it?
Well, that's basically what it does.
Well, no, that's what it does, but I mean in terms of actually how you use it, because that's...
He didn't use the rank operator in its definition. But you can define the rank operator in terms of eaches and enclosed with bracket axis, of course.
Right.
But that's
no. But did you have to
idea.
supply? You didn't have to supply the explicit. He's not thinking about it in terms of transposes. But what information did you actually have to supply?
That's basically what you had to supply.
Oh, right.
that is
Okay.
that is all the information necessary, right? You're saying,
no, I know that. I was wondering if the whole point of, and this is how I've started to think of bracket axis as almost like a syntactic sugar over that idea, right? It's like, instead of having to explicitly rewrite my two transposes before and after, I can just say we'll do this along this axis or these axes with the numbers swapped over, means you get a reversal of the order on top of that, whatever you like.
But the problem is that these transposes are implied by the function symbol in the bracket axis, and the bracket axis has a lookup table that says, oh, okay, we're doing this function today.
It's more the other way around, that the function goes, oh, I've got axis, so I need to do it that way.
No, that's the implementer speaking.
Yeah. Yeah.
Not from the APL's perspective, right?
Yeah.
The APL sees square brackets attached to a function and goes,
yeah,
that's the bracket axis operator.
Yeah, it's not really an operator though.
we know.
That's good.
But really, that means you didn't have to have a special syntax for the axis. You could, instead of a rank operator, you could have an axis operator. It certainly is possible.
Yeah, right. And then
sometimes one is the most convenient to use, and sometimes the other one is most convenient to use. And Jacob Brickman was actually in favor of having both. He says he would like to see us adding the axis operator, but don't remove rank. It's fine for the things where it's good to use.
What did he think of having as having access operator as it is as square brackets or
no? So I asked about
he means to have an
there's no reason to have it be special syntax.
That's what his argument is. Yeah,
I was thinking, did he have an idea for a glyph or was it?
I don't remember him mentioning what glyph.
That's an interesting one. What are we going to use for? Because you've already taken over for depth, which is the nested analogy to rank, and then this is like we're comparing this to rank because it's but
it's
a
rank and
structural
transpose.
thing.
It should.
Oh, that's fun. Yeah, over with a line through it.
Yeah, it should be transpose diaresis, right?
Yeah, transpose.
Circle backslash.
Is that the only triple overstrike? I think there's probably a reason why that's not.
In principle, it's not. Domino is actually a triple overstrike.
Oh, only because divide is already a hyphen with a colon on it.
Yeah. Oh, yeah. I didn't think that would be an overstrike. I thought you'd have that as a character.
No, I think in practice you do.
Yeah.
I think it's just I just think What is the the primitive Unicode symbol? What is the actual? Can we compose Unicode symbols from all? Well, not Unicode. That's not fair, is it? Because that's just
It doesn't even work in dialect today to overstrike
No.
a hyphen with a colon, but I think you could once
Yeah, I
upon a
think the
time.
IME can do it.
Oh,
Yeah.
stencil, quad diamond.
Yes. I've.
Oh, those two carrots. No,
Uh,
and an
I
or.
I feel like
Yeah,
there's still
or greater than less than.
Oh, the great lesson.
I-beam might work with
What's
encode
that?
decode overstrike. I'm sure. I'm
Yeah,
Yes.
but
sure.
those are
Jeff.
not overstrikes. The encode decode symbol up and down tag are not overstrikes themselves.
No. But if you combine them to make an I-beam, I feel like Jeff showed me there were a
Yeah,
couple
yeah,
that
yeah.
still.
There are some input methods you can do that.
Yeah, I feel like there
Yes.
are some which still are there, but it's more kind of sort of backwards compatible, I think.
Yeah, I mean
For
it
whom? I think
works.
it's like a
Uh,
Easter egg, isn't it?
yeah, I guess so. Quad FMT, but not the format primitive. Quad FMT will evaluate certain terminal control characters, including backspace. So I just tried it now.
Oh,
So quad
yeah.
FMT less than backspace greater than backspace quad will give you the stencil symbol. Quad
Can you
diamond.
then use that stencil?
Yeah, I can do an execute on it.
Okay.
Actually, I can't because it's a dyadic operator. But in principle, I could. I could fix a function that uses that symbol inside. Yes, it's a proper. It's not a sequence. It
Wild.
becomes the proper thing. The whole thing is just gives you a single character
That's unreal.
like that. But
So
idea.
someone comes to you and goes, "Who would code like this?" Looking at you, people go, "Well, it could be worse. You could you could have to code using these individual ASCII symbols
Decomposed.
with backspaces in."
Yeah, there have been various spelling schemes for APL that for doing this kind of thing.
I
Yeah.
guess it's not. It's like one. It's like a step away from ligatures, or in a
Yeah,
sense.
which a lot of I know I was reading kind of Haskell and various things going make ligatures so you could have an less than or equal and have put the equals underneath. But yeah.
Yes, yeah.
Yeah.
People who use those languages sometimes like those in their fonts to sort of group things together. And
Others
APLers go,
claim
let's just have symbols for it.
it's a lie, right? You see one thing, but it's not actually that thing.
Yeah.
Whatever.
Whereas we actually have the thing.
Yeah.
Exactly, yeah. This we'd argue their notation is lacking if
Yeah,
you
but
feel the need to do that.
the difference is ability to type it easily.
Duh, yeah,
Yeah.
that is
But
it.
on the other hand, having the actual symbols next to each other, even if they visually are like that, that restricts the language. Right? You can't if you type less than equal to mean less than or equal to, that means you can't have a monetic equal.
Yes.
It just doesn't work. And the same thing if you have less than to make some left shift thing, that means you can't have a monetic less than, and so on. Anytime you have these biglyphs like that, then that cuts down on what the meanings of the glyphs can be. In fact, you already have this kind of issue. If you in some languages, if you write minus minus, so subtract the negation, which should be the same thing as plus, that doesn't work because it has a greedy parser that or tokenizer or whatever it is that thinks that this is a decrement function.
Oh, yeah.
So and then you have to put a space in between them. So minus space minus, which I think is horrible that spaces between the glyphs makes a difference, but that's just me. Anyway, we should round this off. And it's been interesting. We went places I didn't think we would go.
As it usually does, yeah.
Yeah, Silas, you up for joining us another time?
Yeah, no, it's really interesting. Thanks for letting me join.
No, thanks for coming. It's nice to get another perspective as well. And even though I'm a much newer APLer than Adam, I feel like I have fallen into the the mindset where it's like things that I think things that probably are unusual to people. I've gotten used to a bit too much, so it's nice to have that perspective on as well.
Okay, thank you so much to both of you for participating today, and thank you to our listeners.
Right.
Right.